All right, let's look at 65 in the textbook. We'll use this as an example of getting our boundaries across. So we're going to have our upper bound is going to be z equals x squared plus y squared. And our lower bound is our lower bounds. We're bounded underneath is the xy plane, and the region on the xy plane is going to be y equals x equals 0, and x plus y equals 2. So let's get an idea of what this looks like. All right, so the x equals 0 is another way of saying the y-axis. So the y-axis will be one of our bounds. The line y equals x is our favorite line, the identity that shoots through there. And I guess if we want to look at y equals x is 1, I can plug this back in. I get 2x equals 2, or x equals 1. And that means we have a boundary point here at 1, 1. And this line then, when x equals 0, y is at 2, or becomes this. And so the region we're looking to contain everything is this nice triangle down here. And if we look above it, then if we're going to look for what caps these points, when I'm at 0, 0, z is going to be at 0. So z equals 0 there. And when I'm at 1, 1, then z is up at 2. And when I'm at 0, 1, z is up at 1. So we have this region then. There's z equals 1, and there's z equals 2. And so this is our kind of wedge-like shape with the triangular region and this paraboloid coming above it with its own curvature coming across. This means we can set up our integral nicely. If I'm moving parallel to the y-axis, I'm going from the line, well, if I solve this for y, I'm going from the line y equals x to the line y equals 2 minus x. And if I'm moving in x, I'm going from 0 to 1. So it's not a bad integral to move through. We've got moving on our boundaries in y, and then our boundaries in x. So we'll integrate in terms of y first. And we'll evaluate that from x to 2 minus x dx from 0 to 1. Let's do a little playing here. We're going to have x squared times 2 minus x plus 2 minus x cubed all over 3 minus x cubed minus x cubed over 3. I could happily plow along and keep integrating these, but let's try to simplify some of this algebraically. So 2 minus x cubed over 3. I'll do the 2 minus x cubed. So that's going to be 2 cubed minus 2 squared x. Well, let's do Pascal's triangle here really quick. Let's write out. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. These are going to be my coefficients. I'm going to get a cubed plus a squared b plus a b squared plus b cubed. So my a is 2, so it's going to be, oh, and the appropriate coefficients in, right? 3 and 3. So this is going to expand. 2 minus x cubed is going to expand to 2 cubed over 3 minus 3 over 3 times 2 squared times negative x. Sorry, plus. And then it's going to be plus 3 over 3 times 2 times negative x squared plus negative x cubed. And so if I simplify this, so let's make this a little bit simpler now. I'm going to have 0 to 1, 2x squared minus x cubed plus, and now I can write all of these bits back in. So I'm going to have 8/3 plus the 3's cancel. Right, the 3's cancel, and that's 2 squared, so that's 3's cancel minus 4x plus 3's cancel plus 2x squared minus x cubed over 3 over 3 over 3, but 3's canceled, 3's canceled. All right, so that's this part coming out, then in minus x cubed and minus x cubed over 3. Oh, a lot of x cubes in there, huh? So let's see. 2x squared minus x cubed, so that's minus 2x cubed. Plus 2x squared, that's 4x squared. Har. Let's collect like terms here. Let's just start with the cubes. So minus a cubed, minus a cubed, minus a cubed third, minus a cubed third. So let's see, minus 2x cubed, doing that in thirds would be minus 6/3 x cubed. So minus 8/3 x cubed. That's all my cubes. Let's do my squares now. Plus 4x squared. Let's do my regular x's. Minus 4x plus 8 over 3. So a little bit of symmetry going on there. Alternating signs. 8 over 3 and 4s. All right. And now we'll integrate here. So this is going to become minus 8, 3 times 4, x to the 4th, plus 4/3 x cubed minus 4 over 2x squared plus 8/3 x, evaluated from 0 to 1. The zeros won't matter, so I'll put in my ones. So let's see, minus 2/3 plus 4/3 minus 4/2. How did I end up? Minus 4/2 plus 8/3. So let's see, that's 12/3, 10/3. So 10/3 minus 4/2. 4/2 is what, 2, which is 6/3. or 4/3. So we get 4/3 altogether. I hate the math side of these things sometimes, but 4/3 is our answer. Right? This is why there's a difference between arithmetic and calculus. All my calculus was done when I did the integral. Right? But 4/3 is our answer.